To get started, we have AI-powered integration, unleashing the potential of MongoDB Atlas with Azure. We have our great speaker, Zidan from Microsoft, and Aicha from MongoDB. Welcome.
Good morning, everyone. I hope you're hearing me. My name is Zidan, Microsoft CSA. As you can see, I'm also MongoDB community champion, certified developer as a MongoDB as administrator. I have a long history with MongoDB myself, and I'm here to present to you with what we have been up to with MongoDB from the partner side. Alongside me, Aicha, she's similar to my role. I will let her actually introduce herself, and then I will continue.
So hi everyone, my name is Aicha and I'm a partner solution architect at MongoDB, and basically I'm dedicated to exclusively to the Microsoft partnership, so working alongside Zidan across our several integrations and help customer and support with their different projects and use cases. Thank you.
So I think many of you not necessarily are up to what we've been doing as a Microsoft with MongoDB. A year and a half ago, we signed a big strategic agreement with MongoDB. And since then, a lot of kind of developments happened on the kind of collaboration on product integrations and how we make product integration easier for both of our customers. So, and again, all this to make it easier for MongoDB developers and Microsoft Azure developers as well to get the benefit and for both world and both services. So that was, yes. So since that kicked off, we've been across a long journey through integrations, and there are like basically main four categories where the integrations between the two products or the kind of the MongoDB products and Microsoft falling into. So AI analytics generally, and then the new generative AI. Microsoft is leading on the generative AI front, and MongoDB are doing a lot of work with us on that regards. We can also gonna go about the developer tools and then the rest of the infrastructure. So on the AI analytics, Microsoft Fabric, it's a product that we announced a year ago in MS Ignite, and MongoDB is working with us to do a lot of integrations and allow you to bring your data into Fabric. And this is one of the kind of the big push on Microsoft side last year and this year as well. We also have the standard Power BI integrations. I think many of you are aware of Power BI, and they like the kind of the feature set and the ease of use of Power BI. So bringing your data into Power BI directly from MongoDB is something now it's literally easy. Doing all the mapping of the models, Synapse, if you're doing analytics, in a kind of analysis services, if you're coming from analysis services, or you're doing any kind of warehousing, Synapse is a native solution, and again, it has integrations with MongoDB Atlas. Azure Databricks, it's a sister company to Microsoft, and we're doing a lot of work with them as well, and they do a lot of work themselves with MongoDB. The second set of integrations is about AI. So Azure AI ML is one of the key things. So you have your documents in MongoDB, you want to generate the embeddings, you want to choose a model, and you can utilize all the Azure OpenAI to do that step. In addition, you can also use semantic kerneling, which is it's basically an orchestration for machine learning. You can use MongoDB as a vector store, as a input to your input of your vectors, or as a destination after you generating all your embeddings and you want to store it back in Atlas. Microsoft 365 Copilot, it's basically taking a native AI approach and allowing certain features like Copilot to go across Microsoft 365. Microsoft 365, Office, tools, Teams as well. An AI Studio, this is another integration building on a similar pattern to semantic kerneling, allowing you as an Azure AI developer using the Azure AI Studio to be able to integrate with Atlas, reading data from Atlas as a vector store and writing data back into Atlas. Developer tools, you got the Copilot Studio, you got the GitHub, for MongoDB allows you to kind of generate queries, connect directly to your cluster, and just get your data into VS Code, for example. Recently, we introduced Entity Framework. Most of C# developers, they fall in love with Entity Framework, and having the ability to basically build your queries and chain your queries natively on MongoDB Atlas, it's very good feature for them. You also have the integrations based on the data API of MongoDB, things like Power Automate, Power Apps, Logic Apps. This is all part of the Power Platform, and this is basically, again, builds on the integration patterns that Atlas comes or provides as part of the data APIs. And then you have all the other kind of infrastructure integrations. So you have private links, private endpoints, app services, Azure functions. You can use it with Atlas triggers and KeyVaults if you want to have your encryption keys stored in Azure and you want to use them to encrypt your data in MongoDB Atlas. And recently Purview as well, where you can kind of provide a catalog and kind of a provisioning access to your Atlas clusters, basically. And yeah, so basically this is kind of the existing standard connectors for each of our products that works directly with Atlas. So Fabric, you got Dataflow Gen 2 and all the data pipeline. Synapse, you got the Atlas Data Factory, the Azure Data Factory connector. And you can do triggers and Azure functions. For Power BI, you have the native connectors that from Power BI you can directly query your Atlas clusters, and it integrates with Atlas Data Federation, which is a new product, or Atlas SQL, as you might know it as well. And the last one is using Spark Connector to work with Azure Databricks. On the generative AI front, you can use, as I said, open APIs to create your embeddings. You have the MongoDB in-memory connector for semantic kernel. You have the Power Platform connectors, which utilizes Atlas data APIs. And basically on Azure AI Studio, as I said, you can read data in and you can write the data back into Atlas as a vector data store. I'll leave you to hand over to Aicha to show you a demo about how you're using AI with Atlas.
Thank you. So, okay, so for the demo now, I'm going to show you an application called Leafy Hospitals. So basically, it's patient screening that are awaiting for their breast cancer screening, I would say. So what's happened is that first, when there is a patient, he comes, there is an image request which is sent. So basically, it's an X-ray, for example. And then this mammography is sent to the screening system. And so this screening system sends this image for analysis inside Fabrics, where we have our machine learning models that have been trained, that have been tested, and the accuracy have really been validated there. And then here we go in to compute what we call a BI-RAD score. So a BI-RAD score can tell us if the patient have some exposition to cancer, if we have detected any problems within the screening. And from there, we're going to store also those images inside Lakehouse. So basically, in Lakehouse, you can store table files, you can store video, you can store images, you can store any kind of data files data format files that you can have. And from there, those analyses would be sent back to the patient portal so that the radiologist could be able to see if there is any problem, that we can do maybe a biopsy, or we can do further exams for that patients as well. And from there, we can use those computed results and send them back to the MongoDB Atlas database, where from there also we can also visualize the reporting within Power BI. So here we will be using Power BI Cloud. I know we may be more familiar with Power BI Desktop, but here just to illustrate what Zidan was saying, that we have now also Atlas SQL interface where you can have your data, do some analytics in there within Fabric, and then have them back in your Power BI for your analytics as well. So that was first for the analytics, because we really wanted to show you that there are two parts. You have first everything related to analytics itself, the AI, where you have the machine learning models, where we can do the screening, where we can go through that cancer data journey. And then now we can start asking questions about the results of the screening. And this is where we're going to use AI, generative AI features. So what happens is that, okay, I have now my conclusions. I have my screening notes. So I will be asking questions about a patient condition, for example. So I will send a question to know, for example, if a patient is on any kind of medication, like what medication they are on. And you have several steps. So we will send that question. That question would be vectorized using our embedding model, which might be hosted in Azure OpenAI. And from there, we will be storing those vectors into vector search. So vector search is basically our Atlas features where we allow you to store your vectors alongside of your operational data. So without having to duplicate your, maybe to have another system handling your vectors or another vector-specific database use cases. And from there, now if we can use that context specifically to do RAG. So to do RAG so that we can build a prompt and augment our proprietary data with the LLM before we send it back, also using, for example, semantic kernel to kind of have a memory, what we call like a memory store inside the semantic kernel framework. And we can have a rich result that we can send back to the patient portal chat platform. So now just to show you how it will work within the video. So basically you have the Leafy hospitals here, and we have a list of patients. So we have here a list of patients that are awaiting screening. You can filter. We are using here specific full text search facets to kind of see if we have patients that have been booked, fulfilled, and we're going to see, for example, for Lear. So here we're going to upload. So we don't have the material to upload a specific image. So we're just going to upload here sample images here, and we will see metadata. So metadata is related to the mammography that we have done. And then there is a Barrett score, the Barrett score that we have been computed within Fabric. So basically in Fabric, you have your machine learning model that you can export through an endpoint, and then we will send that image as an input to the endpoint. It would be able to have the result. And under the scene, what you will have is here. Like you will be seeing, we have our ML model here. He's doing, taking as an input the data image, and then you will have the Barrett score that has been computed. And here you see, as we have trained in multiple models, we have them archived here. We have the Barrett one. So depending on the level of severity that the cancer might be on, we have the training, I would say execution that we have done alongside the data. So just to show you here how it will work within Fabric, we are really using the image, vectorized image, store it into MongoDB Atlas to kind of train our model, use a sample data, validate it, train it, and then be able to have our working ML model that we will be afterwards exposing through the endpoint. So just going here through the different parameters that we're sending that we're using to train our model, to kind of validate the accuracy and make sure that everything would be working. And we are exposing here, you would see with a prediction where we give him just an image, a JPEG format image, and it would be able to compute afterward the Barrett score. So we have all the steps done now. What we decide to do afterward is maybe there is a problem with that patient. So we decide also to do a biopsy. And again, for this biopsy, we found out the patient has a malignant condition. So again, this is a separate model as well. We are also using a separate endpoint here within Fabric to compute, I would say, the accuracy and to validate the patient condition for this time. Just going through several parameters here and the output schema that we will use to have the metadata that we send to the model. And we will also be storing inside MongoDB to be able also to replicate or to be able to see why we have these results if you are doing some diagnosis about the result that we had in the past. So at this point, the doctor or the radiologist can decide to put here some clinical notes. So here we're just generating some of them using ChatGPT. So we have the clinical notes, we have the conclusions, and the SNOMED parameters as well available. And for example, here I would say there is, we can save the report from there. Okay. And we can, what we will do here is now for the generative AI part. So basically, we have now our clinical notes and the conclusion, but we don't have any information regarding if Lear is on a specific medication, okay? So what we'll do is here we are bringing some information to the system. So here we're saying, we're bringing an information about breast cancer primer, so we will see that Lear is using a specific type of medication, what the description of that medication, what it is, and once we upload it into the system, so here automatically we will be vectorizing that data. And you will see here on MongoDB Atlas, once the data is uploaded, here we're just starting to kind of be able to see the latest document that we vectorized. We have the text chunk here, and then we will see that the file, it's related to the file that we have embedded, and you see your vector embedding. So basically, it's an array of vectors. Yeah, so it's still doing the chunking. So it would be just an array of vectors that we will store alongside of the file. That file is stored in Lakehouse, but the vectors would be stored in MongoDB Atlas, basically. And we're using just the metadata to reference that we have the file on Lakehouse. So now that we have fulfilled the screening of Lear, what we will do is that we can go and ask questions about Lear. So to be able to see if what is Lear condition, what's medication she's on, to ask questions about a specific malignant problem that we have seen in the conclusion. And simple question is just tell me about Lear, tell me about the patient. And then you will see here under the hood, what happened is that you have we are giving to the LLM a context. So basically, we're giving them the patient information. You should be able to give us answer only by relying to the patient information that you have in the database. So we give him the context session, we give him the patient information, and also the patient history, okay? So that this is also to be able to not give the ability, I would say, to the LLM to hallucinate, so to be able to give us answers that he's not sure about. So he will only contextualize the answer based on the information that we are augmenting for the LLM, we are adding to the system. So we can also add a specific, another question. Here, for example, what was the last treatment that we have prescribed? And this was not in the screening node, but it was in the information that we brought into the system. And here now it's able to tell us that, okay, the last system we prescribed for that patient for was the tamoxifen, Clinat, and the riboclips, I would say. So this is prevalent for breast cancer. And again, this is inside the information that we brought through the PDF file, where we kind of give the description of the medication that he was using, that Lear was using. And then here you will, under the scene, again, you will see we have the chat history. So the system, the application is able to use all the history, chat history, that we've provided beforehand to answer. So we will be using semantic kernel here basically as a memory store, so that within the session where the radiologist is connected, it will still be able to provide us relevant information based on all the history conversation that we had with the chatbot, basically. So that is for the analytics. I think I've covered the analytics part and the Gen AI part. And here, just to show you that chat history that we had, basically all the questions that we are sending to the system are also stored into an array where we can replay it, for example, or we can reuse it to make sure that our LLM is efficient, that he's giving us the right information, that the memory store is really, for example, if in the future I'm coming back to ask the same questions, it won't be re-executing the whole process. It will just go and check the chat history and be able to retrieve that to answer that question quicker, I would say. And the last part would be here we are going to switch, I believe, to switch users. We're gonna use the Eddie grant, which is, for example, the healthcare agency manager, and he wants to see some insights or analytics about the breast cancer distribution. So here what we have done is that we have built a Power BI report, and basically this Power BI report is using the metrics that we have computed in Fabric and that we have also sent back into MongoDB Atlas. So all this information basically have been computed using Atlas SQL interface. So here we can see some distribution of the most prevalent data, and if you have top segment, where are for which practitioner has the most patients that have malignant conditions that are more impacted from that cancer, for the breast cancer as well. And you can also see some key inferences. So basically, you can really play with your data within Power BI, be able to represent any kind of feature that you have, map, like geographical or map data distribution, without having to ETL your data to put them in a relational database. We're using really Atlas SQL interface to be able to ask SQL queries on your MongoDB data directly without any third party or any third party tool the third party tool needed. Okay. And I believe that's it for the present, for the demo. Let me just check that we are left. So I will just hand over quickly to Zidan to talk about the developer tools that we have already covered. But feel free afterwards if you have any question about the demo or any kind about the session that we can cover otherwise. Thank you.
So, just because of the time and the keynote, so we're going to keep these two sections. We're going to follow through on the second presentation today. Later in the afternoon, we're going to talk a lot more about the developer tools and the infrastructures. But come around at Microsoft booth if you have any questions. Happy to take them for you. And we'll hopefully see you in the second session as well. Thank you.